Yo, what up YouTube? Kdude here, and welcome back to another devlog on the tower defense game. And this time we have an actual name. So, the game has been named Vault Tower Defense, or VTD, and you'll see later how it's related to the actual game. So, thank you to everyone who joined the Discord and gave feedback on the game. We really appreciated how you guys gave feedback and how you've enjoyed the game so far. If you want to get more info on the game outside of these videos, the Discord server is the best place to find it, so go down, it's in the description. So today we're going to get into how I yet again improved the enemy's performance, take a look at the first boss of the game, 2 brand new towers with unique functions, and having a fully playable game from entering a match in the lobby to getting a victory or defeat and then returning back to the lobby. So enemy performance was already really good, but there was one problem, and that was that the receiving data was a little high. A few other games I tried have around 200 to 300 kilobytes receiving max. Sometimes they're a lot lower as well, but it just depends on how many enemies are on screen. But with 500 enemies and nothing else going on, we were hitting about 300 kilobytes. So I started to look into some methods, and my pal buddy friend guy pally bud dude Foshes was streaming himself working on some client rendering stuff.
On my lap right now.
Now he was doing bit compression, which is way more advanced than what I did in the end, but he led me to a dev forum post made by Atrazine, however you pronounce it, titled, How He Reduced Bandwidth Usage by 60 Times in Astroforce. This post talks about how he reduced bandwidth in his game, and he goes into some other pretty interesting stuff about bit compression, but I needed an easier method. Bit packing is really complex to deal with, and my monkey brain wanted a quick fix, so I used one of his earlier methods, which was vector2 int 16. So this is a type like vector2 or vector3, but different in that it uses int 16 numbers. Now normally numbers are stored as 64-bit floating point numbers. Vector2 int 16 and vector3 int 16, however, are 16-bit signed integers, which is obviously less than a 64-bit number. And since our original issue is that we're sending too much data, reducing bits is the way to go, and this method is easier than actual bit packing. The original post covers this topic infinitely better than I could, so I'll leave a link to it down in the description if anyone's interested. Now we're using a vector2 int 16, but we don't actually need to use it as a position. We can just use it as a number holder to send info like enemies' path or nodes through a remote. Now obviously, since the number would be a 16-bit integer instead of a 64-bit float, we lose the ability to have decimals, and our range goes from about negative 1 times 10 to the 308th power to 1 times 10 to the 308th power to negative 32,000 to 32,000. Now we'll never have 32,000 paths or nodes, so that won't matter there, but for the enemy's HP, we want to have a lot bigger numbers, so we'll just have to send them normally and deal with the extra bits. Of course, the biggest info being sent was the C-frame of the enemy, which is sending position, orientation, and some other stuff like look vectors, which we don't really need to send, and we can, remake on the client. So I changed it to only send the X and Z position of the enemy, and we can get the Y, rotation, and other stuff from nodes, since we can calculate rotation by looking from our previous node to the next node, and the Y position is just copying the node's height. However, since we're dealing with ints instead of floats, our number is losing its decimal, and thus is becoming inaccurate, so our positions are a little bit off. So if we simply multiply our positions by a number on the server, and then divide by that same number on the client, we'll get back something close enough to our original X and Z position. Now we can't go too high with that number or we'll hit our 32,000 limit, so I chose 50. This gives us a max position of about negative 1200 to 1200 on the X and Z axis each. But this is about half a base plate, which is massive itself, so as long as we place our maps at 0, 0, we should be okay. Also, instead of sending the enemy's name as a string, I made it so enemies have an ID, and we instead send that through a vector2 int 16. Which again gives us about 32,000 different types of enemies we can have, but that's still quite a lot. Again, that's not 32,000 max enemies on the map, but 32,000 unique types of enemies. Although 32,000 enemies on the map would probably kill the game. And with this, our sending data with 500 enemies has been reduced from 300 kilobytes to about 90 kilobytes, which is around a 70% reduction. That might not seem like a huge deal, but 500 enemies is probably the max we'll ever have on screen at once, so this is a pretty good point to stop for now. Another thing to note is that we actually added the enemy's HP to the table, so we're sending more useful info than before. Now next I added a way so that you can see enemy's HP. Since we're sending the HP through the client, we can use it. Pretty simply, whenever you hover over an enemy, you'll see their HP and any mutations that they have. Next I made it so that when you have more than one player, enemies will get an HP buff. It's a 75% increase per player, so 2 players is times 1.75, 3 players is times 2.5, etc. Now this is cool. I made it so that the enemies can spawn enemies when they die, kind of like a Moab from Balloon's Tower Defense, or like the old school Trojan horse. Must have been pretty sad to get this cool wooden horse from your Greek pals, only just for it to be a Moab in disguise. Finally, I also added this extra UI to the troop info, which tells you what stat is what. A few people were confused on what the stat was and what it was doing, and that was specifically the kunai knife being pierced, so that's changed. Now to move on to the big part of the video, the first boss. Now the first boss is Kdude. He's this cool robotic cowboy who kinda runs the Wild West. His main deal is that he has a massive health pool of 600,000 HP, even more when there's multiple players, but he's also got a unique attack under his belt. So, every time he hits a certain HP point, like 80% or 60% HP, he fires a few grenades up into the air. These land at random points on the track and actually start spawning new enemies at that point. Now this sounds like a really dangerous ability, but the next troop is this dude's natural enemies, so you'll see how it works. So to start, I made a function which gets 6 random nodes on the map, excluding a few at the end so that he doesn't spawn enemies too close to the end of the map. Next I made a loop which checks whenever his HP reaches a certain point stored in this module, which will contain the HP and what enemies spawn at that point. Then when he reaches a certain point, he'll play an animation and stop moving. Then I made it so that the enemies start spawning at the 6 nodes he provided, and made it be offset by a little time to allow for the grenade animation to play. Next I just made it so that a grenade spawns at each node in order of when they start spawning and make them despawn shortly after. Then I did something similar with the coin drops for Sunny, where I tweened and used tween direction to my advantage to make a smooth grenade flying animation, and that turned out pretty well. And with that, he's pretty much ready. And of course the first thing I did was spawn like 10 of the guys and watch the chaos unfold. Now the reason the grenades only land in the corners is because there's only nodes at the corners. At first I was gonna let this slide since it really didn't bother me too much, but the next troop required me to fix something which ended up letting the grenade spawn mid-track as well, so it kinda fixed itself. Now it's time to get into the first troop of the video, Mason. Mason is a builder who will build traps on the track to stop enemies from going any further. He spawns traps either earliest in the map or closest to himself depending on targeting mode, and gets better traps as he's upgraded. He's also the first troop to have 6 levels, which is unique to 5-star troops. I'll talk more about that 5-star rating in the future, but for now just know Mason is unique. So the 6th level kinda works like in Balloon's Tower Defense, where only one troop of that type can be upgraded to level 6 per player. So 3 players can only have 3 level 6 Masons in total, 1 per player. This wasn't that hard to code as my upgrade system is already really flexible, so all we had to do was add the new level to the module, and then made it so that the UI changes to purple when a troop is level 6. Then I made it so that you can't get more than 1 level 6 Mason, and the UI reflects this by showing that as the max level at level 5. Now the way Mason's traps are going to function is that they'll be placed on nodes. Now since there's only nodes at the corner, he can only place at the corner. So to fix this, I decided to have the map filled with nodes, so that Mason can place traps throughout the entire map. And this is also how Grenader can now spawn grenades at any point in the map, and it looks a lot better than just flying to the corners. Next I made it so that Mason gets all the nodes in range around him and keeps them in a table. These are the nodes he'll be able to place on. Then I made it so that Mason faces whatever node he decides to place on, and made the targeting modes work, either closest node to him or earliest in the track. Now he'll play the placing animation whenever he builds a trap, and a trap will be spawned at that location. Of course we're doing client-sided rendering here, so on the server the trap is just cloning a node and placing it in a new folder. Then I made the enemies get knocked back whenever they touch a trap. I did this by reversing the enemy's speed for a small amount of time. And I actually made the reversing system way back when I originally made the enemies, and I just never had a use for it until now. Then I give the traps HP, so you can see the enemy actually destroys the trap because it took all the trap's HP. And now it'll actually deal damage to the enemies. Here it kills them in one hit, but the way the trap functions is getting changed a little bit later, so it won't work like that. Of course I tested it by spamming tons of traps down, and the enemies can't get past it at all, but they're actually getting hit by multiple traps at once, and getting killed instantly, so I had to add some debounce per troop so that doesn't happen. Next was to get the traps actually rendering. To start, I just placed a trap model down at the spot and rotated a small amount. And this ends up working pretty well. They get destroyed well and seem to be working great. So I placed Masons everywhere and saw how they did, and yeah, it was working. Traps do spawn in the floor in this footage, but we fix this later once we added the new trap models. Next troop on the list is Boombot. Now Boombot is a little robot who likes to dance. He has a friend with him who plays songs for him to sing and dance to, and his cheery attitude boosts the morale of troops around him, buffing their stats. So I thought Boombot would be like what I thought Sunny was gonna be, a painful few days of googling and smashing my keyboard until everything eventually worked.
How did I suddenly stumble into furry porn?
but it ended up being just like Sunny, where I got it done in a few hours. So first I coded all the buffs in. Range increases range, damage increases damage, etc. Then I made it so that Boombot will buff troops in his range. It's mostly attribute based, so client rendering the visuals is pretty simple, and the other scripts can easily get buffs on a troop. Boombot buffs won't stack with each other, so you can't buff the same troop with multiple Boombots, but he can stack with other support troops, so when we add a new support troop in the future, you can stack them. Now for the visuals, first I made the range part increase visually when hovering and selecting the troop, and then I added particles to the troop while they're buffed, easily showing that they're buffed. I also found this bug where multiple Boombots will fight over a troop's buff slot and it spawns a ton of particles. Fixing that, I made a UI which is shown when selecting a troop, which shows which stats are being increased by what, and only the stats that troop has will actually show, so Pierce won't show on Sunny since he has no Pierce. I also made it so that the stat UI is changed by the amount in the buff UI, and it turns yellow when it's buffed, so you can easily see the differences. And he's pretty much done. Boombot is overall a pretty simple troop, but I really like his character, and who doesn't like a dancing robot with a cowboy hat? Now next was matchmaking, being able to start a game in the lobby and have players join in, then loading into a game with those players and the settings you picked. Now the way matchmaking works is that there will be chairs around a table. Players will join the table by walking near it, and they'll be seated in a chair. Then the host of the match will be able to pick all the settings for the game, picking a game mode, campaign, modifiers, and map. So first I just made it so that you can join and leave a table, and then made it so that if you're the first player to join, the setup UI will appear. Then I basically just finished all the UI, had it load all the maps, campaigns, game modes, and modifiers from a module, and then had it show a UI above the table showing all your settings whenever you finish. It also opens up the table so that new players can join. Then I added a countdown from 30 seconds, and when it hits 0, it'll teleport everyone at the table to a game with the chosen settings. This is a long timer, so we just gotta wait a second here. There we go, and now we're in the game. Now, the settings chosen don't actually do anything yet, so let's get those loading into the game. So for now, the only setting that affects anything is the map, since that's the only real thing that's ready. So for now, we're just gonna load the chosen map. Now the map is loaded from what map you chose in the lobby instead of just picking a random map. And it gets the rest of the data from the game as well, for when in the future we can use it. So to finish this off, next I added transition UI for when you teleport, and that works great. Finally, I added this little map projection in the lobby. For now it's basic, but once Roblox adds highlights, I'm planning on doing some more visuals with it. And matchmaking is pretty much finished. You can join a game and others can join your game. You can pick settings, and while they don't do anything for now, they will in the future, and then you can play with your friends. And to top it all off, I also added this ending screen to the game, so when you win or lose, you can teleport back to the lobby. Here's the defeat screen. And then you can see, here's the Alright, I'm just gonna cheat real quick. Give myself a bunch of monies. There we go. And there we go, victory. Now you can teleport back to the lobby and play again. And that's everything to show for today. Now you can fully play a game from lobby to end. There's multiplayer, new troops, and a boss. If you want to keep up to date with the game, you can join our Discord server down in the description. We love seeing feedback on the game, so come join us. Thanks for watching as always, and I'll see you all later. Peace.